Lesson 5.5, Performing Function Operations. Our essential question. How do you add, subtract, multiply, and divide functions? There are 3 problems left on the page for independent practice. Go ahead and take a closer look at those. So I am being asked, given f and g, find f minus g. So here's me splitting my paper down the middle. Finding f minus g of x means to take all of f of x and subtract all of g of x. So my f of x is this function right here. So I have 4x to the third plus 12. I'm supposed to subtract, and I'm supposed to subtract all of my g of x. So here's the g of x that I'm going to be subtracting. The most common mistake students make is they forget to distribute the minus. So I had this 4x to the third plus 12. I am now subtracting this 2x squared. I'm subtracting the negative 3x to the third, which means I'm adding it. I am now subtracting a positive 9, so it's minus 9. Combining like terms, thirds only go with thirds, so 4 plus 3 is 7. Squareds only go with squareds, and constants only go with constants. So this is my entire f minus g of x rule. But I'm now being asked to evaluate when x equals 2. So here's my entire f minus g of x rule. And I am being asked to replace all of these x's with a 2 and evaluate. So evaluating, exponents go first. So this is 7 times 2 to the third power is 8. This 2 to the second power is 4. 7 times 8 is 56. Negative 2 times 4 is a negative 8. So adding from left to right, I end up getting my f minus g at 2 to give me the answer of 51. Now let's check our domains. I need to check the domain of each individual. So the domain of f of x. This is a cubic. Cubics, parent functions, end up looking like this. No matter how much up and down, left or right you do, a cubic will have all real numbers as its domain. So this is all real numbers. Looking at the domain of g of x. It is also a cubic, which is the same as this. No matter how far up or down, left or right, you take this function, he's still always to the left and always to the right. So his domain is also going to be all real numbers. Now we are going to lastly look at the domain of our f minus g of x function. F was all real, g was all real. What do f and g have in common? They both say use everybody. So our f minus g of x is also going to say, hey, use everybody. So his domain is also all real numbers. Our next problem. Given f and g, can I find the f minus g rule? So my domains are going to go over here. So I'm being asked to do f minus g of x, which means I need to take all of f of x and then subtract all of g of x. So my f of x rule is this guy right here. That's 5 times the 4th root of x plus 1. I'm supposed to subtract all of g of x. So all of g of x is going to go right here, and this is your g of x. So that was a negative 3 times the 4th root of x minus 2. So I had the original blue, my original f of x. I'm now subtracting a negative 3 4th root of x, which means I'm actually adding a 3 4th root of x. And I'm subtracting a negative 2, which means I'm actually adding a 2. So let's see. This had 5 4th root of x's, and this said to add 3 4th root of x's, which meant I ended up having 5 plus 3. I ended up having 8 4th root of x's. Constants go with constants. This is a plus 3. So this is my f minus g of x rule. So I am now being asked to evaluate. Evaluate at 1. So I have my entire f minus g at x rule. And these x's are now going to be replaced with 1s. And now I'm going to evaluate. So the radical needs to come first. So this is 8 times. The 4th root of 1 is 1. Multiplying, this is now 8 plus 3. Now adding 8 plus 3 is 11. So my f minus g at 1 gives me 11. Now looking at my domains, I first need to find the domain of each individual. So domain of f of x. This is a fourth root. A fourth root parent function, let's kind of think about that. A fourth root parent function ends up looking like this, where it kind of goes up faster and then goes. This is a fourth root parent function. Because we're adding 1 on the outside, that meant he moved up a unit of 1. So this means, this was the fourth root of x parent function, that means the f of x rule that we're looking at ended up moving up 1, but still kind of having the same degree. It was vertically stretched by 5. So it still kind of looks like this. Domains look at all your x values. So it didn't really matter that it went up. This is still my last x value. So this is the x value at 0. That is still the last x value I use. I don't use any of these guys over here, which are the negative numbers. I used 0 and then all the positives. So I need to say that I am going to use exactly 0 and then all of the numbers bigger than 0, the positive numbers. Now let's go ahead and look at our domain for our g of x. Our g of x is also a fourth root. This minus 2 tells me that I moved down 2. So this guy moved down 2. And because it's a negative 3, that means he was stretched down and kind of stretched this way. We still, domains, are looking at the last x's. This is still the last x value that I'm using, which is x at 0. This line never comes over where the negative numbers are. It lives over here where all the positives. So I use all the positive numbers and exactly 0. So now I need to look at the domain of my new f minus g of x rule. What do f and g have in common? F said use 0 and everybody positive. G says use 0 and everybody positive. They both said use 0 and everybody positive. So my domain of f minus g is also going to say, hey, use 0 and everybody positive. Our last problem, I'm going to split it right down the middle. These are going to be my domains. I'm given f and g and asked to do f minus g. So f minus g at x says to take all of f of x and subtract g of x. So I need to find my f of x rule, which is this one right here. The rule is to subtract, and I'm supposed to subtract the entire g of x rule. This was my entire g of x rule. It's going to go right here. So I had the original blue, and I'm supposed to subtract this green. So subtracting the 7x to the 2/3. This said I had negative 2 of the x to the 2/3, and I'm subtracting 7 of the x to the 2/3. So I'm counting my x to the 2/3. Negative 2 minus 7 said I had negative 9 of them. So this is my f minus g of x rule. Now I'm being asked to evaluate it at 8. So my f minus g at x rule, where all of these x's are supposed to be replaced with 8's. So I have negative 9 times, this is the third root of 8 all raised to the second power. So I actually have, the third root of 8 is 2. So 2 to the second power is 4. Negative 9 times 4 is a negative 36. So the entire f minus g at 8 rule is a negative 36. Looking at my domains. First, you have to find the domain of f of x. This is a x to the 2/3. The parent function of an x to the 2/3 looks like this. There is no adding and subtracting on the inside, which means he is not going left or right. There is no adding and subtracting on the outside, so there is no up and down. So this guy was reflected and vertically stretched, so he kind of ended up looking like this instead. That is still forever to the left and still forever to the right. So my domain of f of x is still going to be all real numbers. Let's look at the domain of g of x. G of x. No adding and subtracting on the inside, which means no left and right. No adding and subtracting on the outside, so no up and down. That's a vertical stretch of 7, which meant this was the parent function. He is now just vertically stretched by a unit of 7. He's still forever to the right and still forever to the left. So g of x still has a all real numbers domain. So now we just need to look at the domain of your f minus g of x rule. F said everybody. G said everybody. So f minus g is also going to say everybody. So his domain is also going to be all real numbers.